good. So again, it's week 3. We're going through sizing a boiler, we're sizing the heating system for a house, and this is a review from what we did on Monday. So we have 3 methods, either using an existing boiler and you just copy and paste. I would say there are a problem with that. What could be the problem, Anatoly?
If it was
That's
first
correct.
time installed wrong, like
Yeah.
counted wrong,
Yeah.
it's gonna be wrong.
Yeah, so what's the point? If you're gonna change and invest into $10,000 boiler, you might as well get it right. So it's not a good idea, but it's very quick. Can be done in 3 hours. You send somebody, boom, they switch the whole thing, it's done. But the best way to do it is to send somebody to do the calculation. A lot of companies do not do that, and I think it's a malpractice. Because okay, you sized it, you charged me, then it's not going to work okay. Or maybe they will ask the user, was it okay, was it heating adequately? What do they know? But if he's not an expert, you should go and send somebody and verify. Second method is using the entire house. And what is the problem with this one? Somebody?
It doesn't account for each room.
Doesn't account for each room. Doesn't account for each room, and it's not going to be as accurate. You're gonna have some mistakes doing that. Then we have the room by room method, which is the one we are learned. It's the most accurate, it's the most common, and everybody will encourage you to do room by room. Another reason why do we do room by room is not all rooms can be counted, you know, unless you don't have, you have a wall to the outside, there is no heat loss. What if you have a wall from the inside? So you should account for only the outside ones. Question?
Could it also be because of the fact that, say, for example, if you did an addition to the house?
Exactly. What if you added an attic? So what if you start heating the closet? You had somebody living in your closet or something. Or you start heating the attic. You added an attic at some point. So okay, I'm gonna have the kids go play in the attic. Question?
Room by room method.
Yeah.
Do people buy the pen and like book or just use computer?
No, there are
program?
software, but again, software is not always very accurate. If you don't know how the software is working, you'll get some wrong numbers, and sometimes it doesn't have, it has standardized things. You cannot add to it. So if you do that calculation by software, you might find like brick wall or plywood. But what if I add to it? What's gonna happen? So you're gonna have to do a lot of ballpark. If you do it by, nobody does it hand and pen. You can do like Excel sheet, but you can do it by hand as well. Do the calculation. But when you do it with the Excel sheet, it's easy to change things and see what will be the outcome. Okay, what if I added this installation? What would happen? And it's you can suddenly see all the changes, and you can weigh. Should I use the R4 or R2? Is it worth it or not? So room by room. I would say this is the problem if you do oversize the boiler. It's gonna cycle a lot, and if you don't have the right size, it's not going to heat up at all. It's gonna be running all the time, and you don't get the right heat. So eventually, you want the boiler to ramp up into the temperature slowly, and stay there, and maintain the temperature. There will be some cycling, but not noticeable. You should see that the heat. Okay. So we said that also before you go and change the boiler, you should investigate a little bit why did it fail. Is it just old age? Did it deteriorate? And look at what is the new technology. Don't replace all things with new things. We talked about the old cars and new cars. Things did advance a lot. We used to have cars that go maximum 12 miles per gallon. Now the standards has changed. There's a minimum of 25 miles per gallon. So that's at least 1.5 improvement. There are cars now that goes 40 miles per gallon. Not even hybrids, regular gasoline engines. So they did invest into that a lot. Even American cars now and trucks have also standards per passenger, how much should be the MPG. So maybe you should invest into new technology. And again, old equipment might still be running now, 30 or 40 years ago, it's still running. So when you change, make sure you get a new model. What's available? And also what changed? What did we add to the first design? And you can look visually and see, you can tell the changes from the new radiators, old radiators, one that is rusted, one looks new. What did you change and what did you add? So if you go and investigate and look at the piping, you can tell that something has been changed and altered in the system. So put an order on that. Okay, so this will be also an iteration, we did that already, but we'll do it again. And we'll try to mention why it is done again. Because it's important, and we need to know all these details. And hopefully you did that last semester and everybody did a good job. This time we will try to do it with more details. And I will give you the floor plans that you can work on at 1:30. So, first thing you need the layout of the house, floor plan. If you go to a house, they have no floor plan, try to go with the measuring tape and sketch some floor plan as accurate as possible with the dimensions in it. It's much easier sometimes to go and do the measurement than to go and look and dig for the floor plan. The homeowner must have just bought the house, he did not get a floor plan, etc., etc. You can manage to do a floor plan by hand. Doesn't have to be very accurate, but you can put measurement on it. Then you need to know the number of the floors. Which floor is heated, which floor is not heated. Are you going to heat the basement? Do you plan to heat the basement in the future? Should I leave you some outlets? Should I leave it as optional? Are you going to heat the attic or not? First floor and second floor. So put the number of floors, because you need to know what is heated and what is not heated. Again, are we going to heat part of the attic? Are we going to heat closets? Which bathroom are we heating or not? So when you put the floor plan, you can decide what is heated, what is not heated. Are you going to heat the garage? Are you gonna work in the garage? You never know, maybe somebody's a hobbyist, he wants heat in the garage. Do you want the heat in the garage to be optional? Like you can turn it on and off, that's another option. There are some radiators where you can turn on and off, you can zone it out. Like Tracy was asking me, what did you want to do? Hot water tank? Or some other zone, you can do that using a switching relay. You can design for that, but not having running all the time. Question?
Well, I don't know if it really pertains to what we're talking about, but if you were to zone out a section and turn it off, would there be the possibility of pipes freezing in that area?
You can drain it. You can drain it, and it depends where it is. If it's a garage, probably it's not gonna freeze. I mean, how close is the radiator from the house?
Well, I mean, if
Yeah.
someone were to leave the door open.
Yeah, so that's something you wanna think about. How often do you want to use that, and are you going to use hot water, are you going to use steam? So that's another idea.
But I use air, never frost.
Yeah, so with the water, it can freeze, and usually you have a lot of frozen radiators when somebody leaves the window open. So you crack the window and you forget about it, and one day it gets really cold, and cold air falls down, right? So it's gonna fall right on the radiator, and it will freeze, and you have to cut that and deal with it. Like for example, my attic is heated, but in the winter I don't use it, so I just go and drain the pipes, shut off the valve, so no more heat. It's completely mothballed. And there are actually valves where you can go and drain. You shut it off and you can push on the stem and you get a bucket and drain that pipe so it does not freeze. Or maybe you can use antifreeze for your water circulating, or some additives. Anyway, there are options. Then you want to get the building material to the best of your knowledge. Look at brick walls, is it drywall? Is the drywall empty inside? Sometimes it's really hard to tell if it's empty or not. You might have to bore a hole and check inside the wall, see if there's anything or not. A lot of times the walls are just empty. They don't insulate them. And there's actually a bore drill where you can cut a circular section, take it out, and put it back and spackle it.
Hole saw?
Huh?
Hole saw?
Yeah, hole saw, so it's called. Okay. We have some of those. So find the materials, walls, floors. It is important also to look at the floor between the two, the ceiling between two floors. And if you're going to heat the two floors, then it's okay. You don't have to worry about insulation much. But the floor on top of the basement is gonna matter, right? You're gonna always have cold floor. And what is the best? Okay, what do you want the temperature profile to be? What do I mean when I say temperature profile? So you know the air in the room is not going to be the same layer, right? It's not gonna be all the same temperature. The floor is gonna be colder. and the top gonna be hotter, which is not ideal. You want the floor to be hotter because you want your feet to be warm and your face to be cool. So that's again another challenge where you want the heat to be from the bottom, not from the top. But usually, hot air rises. That's why we like radiant floor. Radiant floor heating give you very warm floor around 85 and around 65 or within 5 and 6 feet. So that's more comfortable. So we're gonna look at walls, floors, and other materials, windows, inspect the windows. And finally, you want to look at the geographical location. Why does that matter?
Where is, like, how much exposure to sun, wind?
Yeah, exposure to sun for cooling, and also you are going to have to find the design temperature, which is the coldest day of the year, and you can find that online. How close are you to the water? That matters a lot. At least you have to make a note of it, because it means it's going to be a humid area. If it's a humid area, then you might have to consider that when you put insulation. Like if you use the blown-in insulation, it's very cheap, very convenient, but the problem with it is it catches fire quickly.
Cellulose?
Yeah. And also it absorbs water very quickly. But it's very cheap. So it's the cheapest, quickest way to do things. You have a big machine, it looks like a vacuum, that's agitate the fibers and you pump it inside the wall and leave it there. Eventually it's going to absorb a lot of moisture if it's not treated against water. Over time it will deteriorate. So if you're close to water, that's going to be an issue. So you have to think about that, what kind of material you're gonna put in there. Also look at shade. Shade is very important when it comes to cooling, not much for heating. Because if you want to cool the house, look if the house is shaded or if the sun is hitting it the whole time. So shading is very important in this matter. Any question about that? And we say you can have two houses in the same neighborhood, they look the same exactly, but they have 20 degrees difference in temperature based on the orientation, based on the vegetation around it, and based also on the insulation material. Yeah.
Would you add a little for windier areas?
Yes. The wind is important because most of windows are designed to function properly at 20 miles per hour. If you average more wind, probably you need to have more wind, more different kind of windows.
If you're right on the coast and the wind's all the
Yeah.
time, so you might wanna up your.
Yeah, and you might want to put some shutters. You have storm season. If you're in the Cape or if you're in Florida, probably they require you to have shutters because the windows are not going to tolerate all this pressure difference. Some places have more windier than other. If you live in the mountains, probably you have more winds. And also wind is relative to the location. Just because you're in Western Mass does not mean the wind is the same. The wind in Orange or Northampton is different than the wind in Springfield, because again, the mountains does affect the wind.
Is that something you can look up too, like
Yeah.
temperature?
All this data is available. If you look up, for example, weather in Springfield, just Google weather in Springfield, they'll tell you average temperature, average rainfall, average wind. So you get all this information, which makes it a little bit, give you some kind of informed decision on, select material. Any question about that? So we're gonna do this today for the project, try to secure the area, the information. And if you have missing information, try to make a smart guess what is the most common now, or maybe we should put something else. Let's say the floor plan did not have wall material. Okay, I'm gonna go and pick wall material that's very suitable. And you saw from last semester, what was the average BTU for the house?
50, 60.
It was from 50 to 100 actually, depending on the material. That's a lot. That is a lot. That was acceptable at some point, but it's not acceptable anymore. Now we want something around 30 to 25 BTU per hour. Because think about it, this is how much BTU you have to pump into the house every hour. That is a lot. If you think about it, if you're gonna have 100 BTU an hour, over 12 hours that you're heating the house, if you say it's 12 hours, not 24, that's gonna add up to a lot of, let's see how much. No, it's expensive. Let's say it's 60,000 an hour. How much was your house?
60,000.
Okay, 60,000, that's for 1 hour. So if we assume it's 12 hours, that's 72,000. No, 720,000 BTUs. So if I wanna get heat that house with oil.
14.4 million.
Assuming there is 100% efficiency, I'm gonna go with 100 after cutting all the losses. That's gonna be 7 gallons a day, 7.2 gallons. How much is a gallon?
Like
2.5.
a little, I think like a little bit over than regular gasoline.
So let's say $3.
No, a little bit less.
You sure?
Yeah, it's less than the diesel.
Yeah.
No, I'm saying like it's more than gasoline.
Yeah, it's more than gasoline, but less than diesel. So I think 2.75.
In a season maybe like this, but before was like 230 to 40.
Okay, let's say 250. It's gonna be $18 a day to heat your house. For a month, that's for $550 to heat the house.
It's
You
a
don't
lot.
think of it when you fill that tank, but then the tank goes
Yeah.
fast.
Yeah, that's $500 a month. That's somebody's paycheck.
I know a house. It's just over 10,000 square feet, built in the 1900s, like early.
Yeah.
And they had three 330 gallon tanks.
Yeah.
And they used to fill them all up once a month.
Wow, that's a lot.
1,000 gallons a month.
That's a lot. Besides the money, even if you're a filter rich and you have all this much,
That's a lot.
that's a lot of carbon dioxide and combustion going on. So that's a lot. Ideally, you want the house to have the least amount of BTUs, and the only BTUs you will lose is through air exchange. Ideally. If you have a really airtight house and the insulation is perfect, probably you're gonna lose 5,000 from the entire, 10,000 from the entire house, and some from the air exchange to the outside, because you need that to breathe. Which is possible, by the way, if you really make it. Yeah.
I pay for heat like $200 per month.
That's a lot.
Natural gas.
That's a lot.
A lot?
Yeah, that is a lot. You need to insulate your house. That, how many bedrooms?
Three.
For a
That's a
month
lot.
in the winter, that is.
Yeah, that's a lot.
200 a month?
Yeah, that's a lot. So a therm, I don't know how much they charge per therm. A therm is 100,000 BTUs. So probably you're burning at least 2 therms a day. That's a lot. Insulation, man. Summertime.
So how come on the website online it said one term is 999? Were you rounding it up?
100 and what?
999 point something.
I go by
I
100.
don't know.
I always round up to even numbers.
What is this number? CCP for current month?
That's your bill?
Yeah.
Cubic feet or cubic cc per day? I don't know what they're charging you with.
If you make smaller, you will see for one.
Yeah. I'm not charging you per therm. That's actually very interesting.
But it's including hot water.
So they're charging you per cubic feet of fuel. I don't know what is that. You gotta get the unit.
Heated fuel?
CCF.
I have natural gas.
Yeah.
Yeah.
I've never heard that.
CCF. I had the terms. Usually, I look at my bill and it says terms. Yeah, I don't know what is CCF. That's a lot of it. Check it out. It's good to know what's happening.
Yeah.
And by the way, sometimes they charge you before they check the meter. You know that. They charge you based on last year. Then once a year they go and correct it. So nobody actually is going to check your meter. They send somebody once every 6 months to verify. And okay, we owe you some money, and then they're gonna give it to you.
It's electronically like GPS.
Really? That's good.
Or maybe just car drove through the street
Yeah.
and just like catch it the number.
Sometimes have that now, sometimes don't. They still go on with the regular meter. Okay. Questions? It's very worthwhile because it's a lot of money. It's a lot of money. You lose a lot of money, and it's completely preventable. For like maybe $3,000, you can go buy a lot of insulation and hire 2 people, and like you can do it yourself. Go do all this insulation stuff, and a windy day is a very good day to find all those leaks.
That's all
Question?
You said there's jobs like you could just do this.
Yeah, there's few people actually. A lot of companies around subcontractors for like Eversource and what is the other company? Eversource. Columbia Gas.
Yeah.
They will outsource the job to somebody who gets who has certification to go and do these jobs, which is a lot of fun. Okay. Second thing, we got the floor plan. We get the material question.
Can I have a floor plan for our group?
No, I'm gonna do it,
I don't know if we have one or not.
1:30, I'm gonna,
Okay,
I'm gonna do that.
1:30.
yeah. We get a floor plan. So this is the second part. What we're gonna do is label the rooms and decide which rooms are heated, which are not. So for this example, we're not gonna heat the laundry room. This area are not going to be heated at all, or the closet. So this is going to be not included. This bathroom, not going to be heated. This is part of this one, and it's not part of this one. You don't have to heat this room or this bathroom. This is going to be heated by itself. This is not heated. Bedroom, no closets. You're not going to heat the porch. This portion of the, you can combine those two together, or you can have them divided and have different heaters and separate heating system for each one of them. So we have to label the rooms. We get the material, we label the rooms, and for infiltration, let's think again of the heat transfer quick. Only rooms with
Fahad, there's someone at the door.
low. Hey, so only rooms with walls to the outside.
It's infiltration.
And that's for transmission.
And infiltration.
Also infiltration. For infiltration here, rooms with windows and doors. Outside at each wall. So for here, it's gonna be different factor because we have windows in both walls. So it's gonna be a different factor than this one and this one. If you have one opening to the outside on one side of the wall, then that's one factor. If you have two openings, then it's a different factor. If you have three openings, let's say you have a bay window with the room sticking outside, there's going to be a difference. Why is that? I looked into it, and the idea is if you have two openings from different sides, the wind is going to hit you both ways. You're going to have positive pressure and negative pressure, and the possibility of you leaking air is more. So we decide which room. So this room is going to be with an infiltration factor of 0.012. If we have double glass windows that are storm sashed and weather stripped, this one is going to be 0.18, which is less, 0.12, 0.18, and so on. This is going to be, what do you think about that? This is going to be have a door and a window, and another window. If you take this as one room, probably it's going to be 0.036,
36?
if I remember
Something like
correctly.
that.
So it's different. So this is more.
Because it's got two doors to
Three.
the outside
This is going to the porch. The porch is not heated.
and two windows.
Yeah, one door, two doors, and one window. To the outside.
Sorry, it's 0.036.
Yeah.
It's three sides, not two.
Okay. So we label the rooms, just so we can
I guess it is what it is.
look at them. I have 1, 2, 3, 4, 5, 6 rooms. I will use either the Excel sheet, or you can use one of those calculation sheets. I really hope nobody uses this. Let's evolve into the Excel sheet. Bring your computer with you. It will make life much easier.
I don't know how to use it.
I'll show you.
The only problem with your Excel sheet, I think, is at the last section of that.
Yeah.
You have to put in your own values for the
Yeah.
equation.
If you bring your computer with you, I will help you. That's why we do it in class.
When today?
No, I mean, keep
Yeah.
bringing it every Wednesday. whenever we work on it, I can show you how it works. It'll make life much easier, and it will be nearer, and you can change things quickly, and it's easy to investigate. I'll show you how to use it. Okay? So again, what is heated and what is not? So for this house, there are only 6 rooms to consider, not a lot. The walk-in closet are not heated. They're too small, even if you want to heat it, it's too small and you shouldn't heat walk-in closet. The hallway is not heated because it's open to all the other rooms, so whatever heat comes from the room is gonna go to the hallway, so you do not heat up the hallway. No need for that. HVAC room and laundry room is not heated. No need to do that. And again, there's a lot of heat from the washer and dryer, so no need for that. Dining area and living room is combined into one big room. That's a choice, not necessarily. You can choose to do it any way you want. There's make use of corridor doors, those accordion doors you can pull, section out rooms. They do work. Even though air is invisible, you don't think about it, you can isolate air. Just a freaking small curtain can really isolate 2 rooms. We used to do that back in the days in our dorm room. We just put a curtain between the kitchen and the living room, and it does work. It does isolate air. Remember we talked about air curtains as well? For a lot of stores, they have an air curtain, you open the door and air blows. That actually does shield and insulate air. Question?
What about when they have like the beads and stuff like that? Like, does that?
It does work a little bit. It's fascinating, but it does work.
Yeah.
Funny, huh?
Yeah.
It does work because air is sticky. Air does like separate. Even a screen does help a little bit. But if you have one of those pull accordion doors, it's even much better. If you don't need to cool that room or heat that room, it does work a lot. Okay. Dining room and living areas are combined. The kitchen will need the heat since it's facing the outside. I will not be getting sufficient heat from the dining area. Look back at the kitchen. Yeah, this is gonna be its own room. You cannot combine this with the dining area, so you're gonna consider that as itself. And for this, there is no space to put radiators.
So you can't put the kitchen, dining area, and living room as one and treat it with a factor with 3 walls on the outside?
No, you can't because where are you gonna put the space here? You're gonna put them here. It's gonna take forever for the air to go all the way to the kitchen. So for here, either you're gonna have a kickboard
Yeah, but why can't we do it with our calculations for heat loss?
as one big room.
Yeah.
You could, but I don't think it will get sufficient heat this way.
Really?
Because this is completely open to each other. This is the kind of section. You're gonna have to put some kind of fans or something to push the air here. Otherwise, it's gonna be significantly colder than the other side, especially if you have a window here.
Yeah.
So you might need some kind of heat source in the kitchen.
But our calculations would still end out the same if you treated them
Yeah,
separately, right?
it's gonna be the same.
That's what I'm getting
Close
at.
enough.
But then afterwards, go through and add kickboard.
Yeah.
Radiators.
And the kitchen, you're always gonna have a lot of fans and vents, so probably you need to get some kind of heat source. Probably not much, but you need something. Okay? The kitchen will need heat. The porch is included. So you have to not heat it, so it will treat it as unheated space. However, it's not fully outside temperature. It's gonna be different. So there's a consideration for walls when you go into the book, the H22 book. It says exposed wall to unheated space. It's not going to be 0 like outside. It's gonna be probably 10 because there is some heat leaking into it. However, if you consider the porch as outside wall, you're gonna have the temperature as outside. So either 0 or 10, and there's different factor for that. So that seems easy and reasonable. Just follow logic. Think about the floor plan, follow the logic, what would be here, what would be not. And now we know about air leaks, we know about transmission, so where would the heat go? Question?
You mind going back to the side of the floor plan real quick?
Yeah.
And are those closets there, are those, do we ignore the volume
Yeah,
of that, so we don't include that into the,
that is correct. This does not get included in the volume. It's gonna be closed.
okay.
Don't include that, then include this. We do not include this area.
We're just assuming they're gonna be heated by transmission from the room, then.
They're gonna have some transmission and some LED,
Yeah.
but it's not significant.
Okay.
So you have to exclude it?
Yeah. So
How
when you do
far
that,
is-
yeah, when you do the infiltration, you're gonna calculate the volume, right? But it's not gonna be the volume of the closet, it's gonna be the volume of the bedroom. The closet's gonna be half full with clothes and stuff, so the volume is very insignificant. So you should not include it. If you include it, it's not gonna be a big deal, but you don't have to.
Right, and you said don't do the porch either, right?
Now, unless you wanna heat the porch, but this is all glass, it's gonna cost you a lot of money to heat it. Okay? Questions? Yeah.
What if like the closet's like on the outside wall, like would you have to heat that or?
Good question,
Like
good
your-
question. If it's in the outside wall, it's gonna be cold, no, you don't heat it. You don't worry about that, it's gonna.
But we still worry about the transmission losses and,
In here,
yeah, right?
it's not gonna be that significant, it's gonna heat the closet, then come over
So
here.
don't worry
Yeah.
about that and the walk-in closet,
Yeah.
don't worry about it.
Okay, for example, bedroom 4,
Yeah,
for transmission and infiltration, we don't count closet at all,
nope,
like with area amount or something
no,
like that.
no, we don't do closet at all, leave it out. If you include it, it's not gonna be a big sin, you know, it's not a big deal, it's very small. It's not gonna add much to your heat loss or infiltration as a volume. Okay? And again, we are kind of summing all the BTUs, it's not gonna be completely like with one BTU or 10. We're talking about 60,000 BTU an hour, so.
That's not bad, it's good.
50 is, 50, no, actually, we would love to see better than that. Okay,
We have to guess, if we were looking at this drawing, we would have to guess the size of the room if we were doing that.
which one, for the one in here?
Right, I mean, like,
Yeah, it's not giving, we're gonna have to,
do some
yeah, measurement. So the floor plan, I'm giving you will have some dimensions in it. These are the factors, so I would say, actually, you're right, Chris, it's 0.036. One side, two sides, three sides. Entry hall gonna be 0.036, it's a lot, because we're opening the door, and we're letting air in. Sunrooms, 0.054. So we're gonna use, this is with or without? This is with storm sewer, we're gonna use this one.
Does that entry hall, is that like assuming that it goes right into a hallway, not
Yeah.
a room?
Yeah. Like if we look into the floor plan, we don't have an entry hall here, but if we have a big door in here, or in this side, probably is gonna, you're gonna open the door and all the oil will come in. That's why the porch is kinda useful, especially if you have a door in the porch, so you can have less air exchange. Every time you open the door, a lot of air will gush out. If it's cold air, or a lot of air will come in and cool the entire room. Like if somebody opened the door of for this building, within 2 seconds, you will feel that cold air coming all the way here. That's why we have two doors. Okay? So I will stop here. We'll continue